Welcome. In this video, we're going to explore how to use Polypad as a tool in mathematics for students to do some exploring and hopefully gain a good understanding of what it is that they're doing. So Polypad is a tool. It was created by a teacher who really wanted students to understand what they were doing. And so we created the tool as a way for students to play with mathematics and to really make sense of some ideas and some concepts. And it's been around for a little while. He's grown it as he went, and it was recently acquired by the company called Amplify. So we're going to start into some of this today. We won't get to cover everything, but hopefully we can kind of scratch the surface on a lot of different things and give you some indication of other ideas that you might like to explore. So Polypad can be found at polypad.amplify.com. I'll put a link in the description as well so you can have access to that, or you can just do a search for Polypad and it should come up. So when you get to the Polypad homepage, you will see a screen that looks like this one. You can see the graphic here kind of illustrating a lot of the different tools that students can use. So whether that's 10 frames, rec and recs, tangrams, algebra tiles, a whole bunch of options. So we're going to start looking into some of these, how to use them, and maybe a little bit about how to play with them in math. So we're going to click on the Launch Polypad button here on the screen. And when we do that, we get to a canvas. Now Polypad is a very robust tool. We can actually create worksheets for our students and have sort of like a class. We're not going to get into that today. We're just going to talk a little bit about the tools. So students don't need to log in if they don't want to, or if you don't want them to. It could be just as simple as going here and starting to play. Now you'll notice on the left hand side are a whole bunch of, I'll call them toolkits or toolboxes, categories, and kind of look at some of those categories today. So the geometry one was open when I got here. I just closed it up because we're going to start looking at numbers today. So when I click in the numbers option, we're going to explore a few things, and I think I might start with the number tiles and number cubes. And when you do that, you can see all of the tools that are available here. So these are what would often be called base 10 blocks. A great way for students to explore place value and how the decimal number system works. So for example, if I wanted to drag out a few of these, you can get students to kind of think about how could they count and figure out how many blocks or cubes are in each of these. So I can kind of group these together and see, and then they can kind of make an estimate of how many are going to be there. So one of the things that I might do is to click on this split button, and you'll notice that this square, each of these green squares has 10 by 10 cubes in it. So if we split it, what happens is it actually splits it from sort of one block of 100. I'm just going to back up here a little bit. We'll work with one of these for now. So we'll split it. It split it from one block of 100 to 10 blocks of 10. So you can see that there are 2, 4, 6, 8, 10 of these blocks. Each of them has 10 blocks in it. So students can kind of see that relationship that, oh, 10 of the 10's cubes should make a 100 block. And we can kind of go from there. Sorry, some of those aren't lining up. Now, if we wanted to, we can actually group those back together. Just click on the merge button and you can see. But I'm going to split them apart. And I just want to show you that you can split them apart even further. And as you can imagine, when we split each of these rods of 10 into further, it will split them into the ones individual cubes here. So again, it's a quick way for students to kind of get that relationship between the ones, the tens, and the hundreds. So you can kind of see that. And then you might take this a little bit further and even get into the thousands here. So it's a great option looking at those base 10 blocks. The trouble with base 10 blocks, I love the physical ones, but the trouble with them is that they are very expensive and maybe hard to keep sort of organized. So that's the base 10 block, great for place value. Let's look at, we'll just kind of go through the list here. We probably won't hit everything, but maybe we'll hit a few things. So maybe I'll just jump to these. I'll just show you the number bars. So these might look familiar to you. These look a lot like Cuisenaire rods, and you can certainly use them that way. They do have numbers written on them, so if you wanted students to, find out, what a 4 block plus an 8 block was, you could kind of have them play around and see what that's going to look like. There's an interesting feature here as well. I'll just highlight it, is this play feature, and it plays a musical tone. And the length of the tones are proportional to the size of the bar. So it's an interesting way to get students to kind of experience the numbers here in a different way. So some of you might wonder, well, what about the numbers on them? When we do these as in Cuisenaire rods, sometimes we'll use them for numbers, but sometimes we'll use them for fractions. Is it going to be confusing to have 10 written on them? Hopefully not, but if it is, we'll talk a little bit more about this when we get to the fractions section. Also, there are some number frames. I probably won't spend a lot of time here, but if if you wanted to look at 10 frames, so this would be great for primary students or students who are just learning about 10 frames and their numbers, that might be helpful as well. But I do want to get into these number cards. Now, on the surface, these number cards look pretty basic, and you might say, well, okay, I can drag out a 2 and a 3. That's great, but now what? And I guess some of the things that you could do with these number cards would be to add the 2 and the 3 together, and it just will give you 5. I'm going to get rid of that. So let's say we wanted to do, let's do 13 and 19. So we'll add those together. So if I don't see a number card that I want, I can just type it in the space down here. So I'm going to type in 13. And now I have a block for 13. I'll type in 19, and I have a block for 19. So if I wanted to add 13 and 19 together, we could go ahead and do that, and you can see that it kind of helps us out. It says that's 32. But now if I click on that 32 and I choose split, what will happen is, you notice it splits it into the 10s and the 1s. So it didn't split it back into the original numbers that I started with. It split it into the 10s and the 1s so that we can. And again, we can split that together, and you can see that it took the 30 and split it into 3 individual 10s. It took the 2 and split it into 2 individual 1s. So just a nice way to see the connection, again, between the 10s and the 1s. And we can take this a step further and just say, hey, let's split this even further. Take a guess at what's going to happen here. If we split it further, take all of those 10s and split them into 10 ones, and you can still see that we have a column here of 10 ones and a column beside of another 10 ones and another column beside that of 10 ones. So there's the 30 and here's the 2. So again, I can highlight these, merge them all together, and get 32 just to confirm that that it does in fact work. So splitting and merging works out really well here. Thing that you can do is deal with some adding and subtracting of negative numbers. So this might be an option for students. So if I say I wanted 3 and negative 4, I can just click the negate button here, and we can kind of see what that's going to look like. And the nice thing about this is that we can split these, and you can see that the negative 1 and the positive 1 form a 0 pair. The negative 1 and the positive 1 form a 0 pair, and we're left with negative 1. So a nice, easy and visual way for students to explore that sort of addition of positive and negative numbers. And we can see our final answer there being negative 1, just to confirm. So we'll come back to some of these numbers a little bit later on once we get into solving equations and things like that, just to sort of play around and try to use some of these, but that's something that's useful there. And I think it can help students move from that sort of concrete to the abstract. So if they see it and they experience it enough time, they get the sense of those, especially those 0 pairs combining to give 0, and then to see what's left. Alright, so let's move on now to the number line. So the number line is exactly what you might think. It's a number line, and we don't have to go from 0 to 10, so I might want to use this for integers. So we might go from negative 10 and I don't want to go just to 0, I'm going to go to positive 10. So I did that just by clicking on the, I guess you can't really see my mouse there, but I just clicked on the rightmost handle there and dragged that out, and we can do the same on the left side if we wanted to, just to drag it out and make it look a little bit longer. So this is a good way for showing what addition means and what subtraction means. So for example, if I start at 3 and I say, hey, I want to do 3 plus let's go 4. So I'm at 3 and I want to add 4 more. So there's 1, there's 2, there's 3, and there's 4. So 3 plus 4 equals 7. And students can click at the bottom here, just on this toolbar at the bottom, the drawing tools, click on a pencil, and they can kind of write out what this means. I'm going to do this with my mouse. It's not going to look very good, but hopefully you can see what we're talking about here. And if you don't like that color, they can change the color just by clicking on the little colored circle down here and have a palette full of colors to choose from. So that's the 3 plus 4. That's not too difficult, but maybe you want them to do 3 plus negative 4. So we're going to start at 3, and we're going to add negative 4. So that means instead of going to the right, we'll go to the left. So we'll start at 3, and we will move 1, 2, 3, 4 over here. So 3 plus negative 4 gave us a total of negative 1. So that's one thing we could do here. Now, an interesting thing to do to help students kind of explore this might be to say, hey, start at 3, use addition, and use the addition of some positive numbers and the addition of some negative numbers. So make it a two-step kind of question, and see if you can end up at, let's say, negative 1. So what that might look like, just let me get some of this stuff out of the way here. So if we start at 3 and we want to get to, I'll just mark our target here, we'll get to negative 1. So we want to do some adding positive numbers and some negative numbers. We've already got 3 plus 4, so let's stick with that. And we want to get to negative 1. So what is it that I have to subtract to get there? So students can then start to play around and write their own number sentences. You can ask students, are there any other ways that you could do this? Well, a student might say, well, instead of starting at 3, I'm going to start at, instead of going from 3 to 7, I'm going to go from 3 to 9, and that just means that I'm going to then choose, there we go, to go back even further, and they can write some number sentences that go with that. So again, a very visual representation. A lot of students, when they start working with integers, like to use the number line to kind of move themselves along, and this gives them a quick way to be able to do that. And the nice thing is it's easy to kind of get rid of stuff when you're done, and then you can start fresh. I've written a bunch of stuff on the screen. I should talk about how to get rid of that. In order to get rid of that, I click on the drawing tool, the pen here, and the last one on the right is an eraser, and we just click on all of this and get rid of it so that we can start fresh. So that's how we can use the number line. We can use it for adding and subtracting integers, which is great. You can just, if you're using this in younger grades, you can certainly use it just dealing with positive values. And maybe instead of going from 0 to 10, you want to go to 0 to 20. And the nice thing is that we can kind of make this go as much as we want. And I didn't mention this earlier, but I should have, is that we can change the step value. So maybe we want to show it going up by 2s or 3s. So, I'm curious to know how long it would take students to realize that these are really just the multiplication facts for 3. 3 times 1, 3 times 2, and so on. So that's an interesting connection to make as well. All right, while we're in the number, I won't spend a lot of time on it, but I think it's pretty cool, is these prime factor circles. Dan Finkel, who runs the website Math for Love, has created a game called Prime Climb, in which students, players really, get to see these numbers a lot. And what I love about these visuals is they really give a good indication of the connection to numbers. So if I pull out 12 here, for example, 12 is made up of two orange and a green. Well, the orange is represented by the number 2. I'll just drag that out so you can see that. So that really tells us that the 12 is made up of 2 oranges, so 2 2s, but also a green, which is a 3. And I've just dragged those out, but what we could do is just take the green and drag it out of that circle, and now we can see what's happening. So we get to see the prime factorization of 12 here, and how it's made up. So it's a great visual representation, but the interactivity I find pretty neat. So for students to kind of get to know their multiplication facts and to be able to manipulate numbers and change things around a little bit. You know, for example, I can see that 12 is now 6 times 2, or I can see that it's 4 times 3. And they can see all of those factors, which is really a foundational understanding. And once students can understand that, not only can they do basic number facts, but when they get into grade 9 and grade 10 and they're trying to find factors of numbers, whether that's common denominators or whether that's factoring polynomial expressions, that's such a powerful tool. So again, it's a fun way for students to explore this and to really kind of get to know these facts. So great little tool, kind of built right into the Polypads. All right, so we've done a lot of work with numbers. I'm just going to quickly show this number grid. So I just clicked on number grid for 2 reasons. One is that you can see an addition table here on the left, or multiplication table, so students can work with a multiplication table. Great for identifying patterns, so if you wanted students to see the different patterns. So for example, I might say, highlight all of the perfect squares or all of the factors of 3, and we can just go through. If we're going to do the factors of 3, we should be able to just change. Oh, it changes all of them. I was curious to know if we could just change some of those numbers, but students could grab a pen, for example, and circle all of the factors of 3. Well, we've got factors of 3 here. And then they might actually notice that, oh, well, those are the same as these numbers in the row with the 3 in it, and so on. So finding all those fun patterns and stuff within the multiplication chart is pretty powerful. And then I'm going to get rid of that. I want to show this. I love area models, so this area model is pretty cool. Anybody that's taught grade 10 academic or applied math, really, for that reason, probably recognize these as algebra tiles, which we'll get to in a minute. But that aside, I want you to kind of think about what we did with, see if I can go grab some of the number tiles here. So I'm just going to drag these out just to remind us of what these were. Notice we're kind of one level of abstraction deeper, I guess, with this set. You can see that the green here fits perfectly over the green, the blue fits perfectly over the blue, and the orange fits perfectly over the orange. And that's not done by chance. So the green square here is 10 units by 10 units. I'll just jot that down so we can see it. So this is 10 here by 10 over here, and so on. And what we've done is we've created a rectangle whose area that we can find, and each one of these blues was 1 unit in this direction, 10 units in this direction, and then each one of these oranges is 1 in this direction, but also 1 in this direction. So what we've done here is we've created a rectangle that is 13, well, that's a bad looking 3, sorry about that, by 12 in this direction. And so what we can do is we can start to look at, well, what does 13 times 12 equal? So 13 times 12 should be just the area of this rectangle. Well, we know that this section right here is 10 by 10, so that's 100, sorry, there we go. And this is another 100. And each of the blues is 10. I won't write all the 10s in, but we can see that there are 1, 2, 3, 4, 5, 6, 7 10s, which is 70, and then 6 1s. So we get 276. So nice way for students to kind of play around and create some area models. And I think that's a really powerful tool for students as well. and that was just found under the number grids. So, you know, again, students can build this using the base 10 blocks, but I like how it's all set up here, because now you can get into multiplication as a tool. All right, I'm gonna get just spend a little bit of time cleaning this up, getting rid of a bunch of stuff that I have on the screen, and then we'll move into some other things. All right, next on the list, we've explored numbers a lot. Let's move into the next section, which is fractions. Now, I think what I like about the fractions is that it makes that whole process that we do with fractions that students find difficult very visual and very concrete. So I mentioned earlier the Cuisenaire rods, and you can see them here. So we can actually play with these. I'm going to leave them as fractions, but if we wanted to, we could get into 2%, decimals. Let's keep them as fractions now. And we can kind of mess around with these the same way that we would do the actual fraction strips, physical fraction strips, pardon me. But the advantage here is the ability to quickly regroup things. So I'm going to start with the quarter. So I'm going to drag out 4/4. And so you might have students, you might ask students, well, what's another fraction that this would be equivalent to? Well, we have 4/4, and maybe they'll pull out 2/2 and say 2/2. That's equivalent. What's nice here, though, is that we might decide, instead of asking what's equivalent to 1 whole or 4/4, is what about 1/2? Now, I could have students sort of say, well, I'll imagine that only half of this is here. But the nice thing about the digital tool is we can change how this half looks. So if I click on the triangle located on the right side of this orange bar and just drag with my mouse to the right, you can see that now half of this is colored and half of it is shaded. So I can actually visually see that I'm only talking about half of it, half of the big bar. Now instead, I might want to actually have that shaded option not even present. So if I just click on with my mouse, click on the the handle on the right hand side of the fraction and drag it inwards, you can see that the other half that I didn't want disappears. And we can do that with fourths as well. So let's say we were working with this fraction 1/2, and I wanted to look at what's equivalent in terms of fourths. Yes, students can see that, but maybe it's helpful for them to grab that bar and just see it like this. So that's one thing that you can do with fractions, is explore equivalent fractions. The other thing that's really handy here is the ability to add these together. So adding and subtracting common denominators is an area that students struggle with. Some of it might be because they struggle with their multiplication facts. Some of it might be because they don't understand the process of adding and subtracting fractions. So the nice thing here is, if I'm going to take 1/2 and 1/4, we know that these don't have a common denominator. Yes, I could stick this on here. And based on the work that we've already done, students might know that this is equal to a whole. But if they don't, or if you're working with other fractions, in fact, let's get some other fractions here. If they're working with other fractions, let's say we're going to take 2/4 and 1/3 and add them together. We could do this, but we have no idea what fraction of a whole that is, or even if it's more than a whole or less than a whole. We could probably figure that out based on what we know about fractions, but students may have a hard time with that. What's really nice about this is that we can grab any of these fractions and we can rename them. So if I rename, there's two options for renaming. There's renaming sort of as more granular sections, or as larger sections. I'm going to rename this as a smaller section, and I can see that my 2/3 is equivalent to 4/6. And if I have the same denominator with my fraction, I could just count how many 6 there are. The trouble is that if I rename this fourths, I don't get 6. Oh, what happened there? Something funny. Oh no, I do get 6 right there, sorry. Because we were doing 1/2, which is 3/6. So now I have a common denominator just by renaming my fractions, and if I'm going to add these together, I can count this up and say, well, that's 1, 2, 3, 4, 5, 6, 7, 6. So if I were to write that out, we started with, I guess we started with 2/3 plus 1/2 I guess we did it as 2/4, sorry. And, oh, we didn't do it as a fourth, sorry, we did it at half, as 1/2. We could do 2/4, we'll do that one in a second, or maybe one that's slightly different, a little more challenging. And students can say, oh, that 2/3 was equal to 4/6 because they saw the division here happening. I'm running out of space here. Plus, so we had 4/6 plus 3 more 6. And we got a total of 7/6. And students can write that on here. As you can see, it's a little bit cumbersome. I'm using a mouse. It would be more challenging, I think, with a trackpad on a laptop or a Chromebook. But they could also write it on paper, right? They've done the thinking, they've done the manipulation here. They could certainly do that on paper as well. So that's a possibility. Let's try maybe one that's a little bit different. So let's do 2/5 plus let's do thirds. 2/5 plus 1/3. So the idea here, again, maybe I'll just write out the question so we don't forget. I'm likely to forget. So 2/5 plus 1/3. Well, our first goal here is to rename our fractions. So we're going to click on the fifths. So I'm going to click on the thirds. So I'm going to click on the denominator that's smaller and try to make it equivalent. But you'll notice here that I didn't get fifths. I got 6. So now I can just kind of keep going back and forth until I get a denominator that's common. Hey, there we go. I have a denominator that's common. So my fraction then becomes 2/5 is the same as 1, 2, 3, 4, 5, 6 15ths. Plus the 1/3, which is equal to 1, 2, 3, 4, 5 15ths. And so if I put those together, you can see that we end up with 11 15ths. So the idea here is that hopefully over time students develop the know-how. They see what's happening and they start to realize, well, this common denominator comes just from multiplying the denominators together, in this case, to give me 15. So they start to realize, look for the lowest common multiple of the denominators, and hopefully they start to realize also that that changes the number of parts in the numerator as well as we find equivalent fractions. All right, so that's the fraction part. One easy way to look at fraction tools. And let's move into some algebra. Try to keep this fairly quick and highlight some of the key points, because as I say, we could probably spend hours going over all of this and exploring. Let's get into some algebra. A couple of fun tools in algebra. The algebra tiles, as I mentioned earlier, we'll kind of spend a little bit of time looking at this. In fact, let's do that right now. So if you think about collecting like terms, for example, you might have 3x's plus 2 more, and to that you're going to add 2 more x's plus 4 more. And what can happen here is it's pretty easy to highlight a few of these and then copy them and paste them. So, all right, so if we're going to add these together, students really understand. Like if I just write, what do we have here? We had 3x plus 2. And over here, we're going to add to that, oh, sorry about that, 2x plus 4. And we're going to add these things together. When we write this on paper, a lot of students think just add these two together. They see the 3, they see the 2, and they think, well, we can just add that together. And that's just going to give us 5 of something. They often don't know what that something is, but we can just add those together. Once you see the tiles, they realize very quickly that, well, the x's here and the 1's here are not the same. So they start to realize that, well, we can group the x's together and have all of these, and they can actually count them and say, oh, okay, well, that's equal to 5x, and then they can group the 1's together and say that's equal to 6, and that's pretty easy for them to see. So collecting like terms is easy. You can get into, some x terms and some y terms, some positives and negatives. So I didn't do the negatives. One of the nice things here, we'll talk about that later, I guess. We can have negatives as well. So if you had a 3x minus 1, you can have the minus 1 here, and you can collect that with your positive 1. And again, that zero pair that we talked about earlier works here as well. All right, so that's how we can use algebra tiles for doing that. We can also use algebra tiles for solving equations. So for example, if I had 2x plus 1, let's do equals 3. I'll just grab 3 from over here. So this equation is 2x plus 1 equals 3. So you can talk about that idea of whatever you have to do to one side of the equation, you need to do to the other side. So for solving this equation, how do we get rid of this plus 1 on the left-hand side of the equation? How do we get rid of that? Well, we could just take it away. So we could just take away this 1 here. Well, if we take away 1 on the left side, what do we have to do on the right side? And again, students can keep track of the steps that they're doing here. So it's not just kind of moving blocks around, but it's actually trying to work at translating what they just did into an algebraic expression. So we subtracted 1 from both sides. I sometimes will write that like this. Should have maybe written that a little higher up, but so then we'll get 2x is equal to 2. And then each of these x's is equivalent, so we have to split our values, our ones blocks on the right hand side evenly, and so we end up with x equals 1 or x equals 1, depending on how you look at it. So what we just did there to talk about that with students is we just divided both sides of this equation by 2. We split the x's in 2 so that the x's were individual, and that meant we had to split the other side evenly as well, dividing it by 2, which gave us a final answer here, of x equals 1. Now you might say, well, what about if we have negatives? So if we had, let's say, an expression or an equation like 2x minus 1 equals 3. So if 2x minus 1 equals 3, again, we can just build that with our algebra tiles. Here's our 2x. I'll just grab 3 of these blocks over here. There's our 3, and we need a minus 1, so I'll just grab a minus 1 block. And this really gets at that understanding of what's happening in terms of integers. So if I have my 3 blocks over here, I've got an equal sign here. What we did before is we said, well, let's just take away that numbered value that was on the same side as the x's. Well, if I take away a negative 1 on the left, I have to take away a negative 1 on the right. Well, there is no negative 1, but we can add in a 0 pair. Let's add in a negative 1 and a positive 1. So again, that's a 0 pair, but I'm going to add that negative 1 in with a positive 1 so that then I can take away a 1 from both sides, take away a negative 1, pardon me. So when we write that out, what we did is we took away a negative 1. And hopefully, by the time you get to this stage, students understand that when you take away a negative 1, that's the same as adding 1. So here we're left with a 2x over here minus a negative 1. You can see that there are 4 singles on this side, so we get 2x is equal to 4. Well, sorry, my writing is getting worse as we progress here. And then again, you take those 4 individual boxes and you split them up, and dividing by 2 because there are 2 of these x's. Had there been 3 of them, we would say, well, let's split them evenly among the 3 x's so that each is the same. Now, I often get the question about, well, how do you deal with fractions when you're dealing with these algebra tiles? And if you've ever dealt with real algebra tiles, or physical algebra tiles, that's the word I was looking for. You can see here that x equals 2. You can't actually split them, but there is fairly recent, maybe within the last year, I believe, you can actually split the algebra tiles. So I might decide, hey, I'm going to split this algebra tile, and you can see, I don't know if you can see it very well, but that algebra tile is now split in half, and we have 2 halves. So you can actually get to a point where you're dealing with fractional values as well. So fairly new tool, so you can extend this goal or this thinking with algebra tiles into the negatives. All right, we're getting a little bit long here, so I'm just going to try to wrap things up with one more tool. It's probably one of students' favorites, I think, because it totally makes sense of everything we tell them about solving equations. And I'm going to click on the balance scale. Especially when students are first learning how to deal with solving equations, we often talk about sort of that balance scale analogy, but in Polypad we can actually build that balance scale. So I'm going to do that. I'm going to click on balance scale. There's a scale here, and you can do lots of interesting things. I don't know if you've ever tried those Solve Me mobiles, basically like algebra puzzles without the numbers, algebra puzzles with pictures, I guess. So you can do things like this and say, okay, we've got one of those and one of these. Those two things are balanced. Well, how many of these do I need to add in? You know, what do I need to add in to make these balanced? So that's where students can start this exploration, is kind of looking at shapes. But eventually you're going to get into some numbers. And I just want to show you how this scale works so you understand it before we get too far in here. So for example, let's say I wanted to say that x is equal to 4. So I'm going to go to, I can go just about anywhere I can find an x, but algebra tiles is a nice easy one. Some students or some teachers will use, you know, these values, these different symbols to represent x. That's fine too. That's a great place to start. I'm going to say there's my x, and then I'm going to go back up to the numbers, and I'm going to grab those number cards that we talked about earlier. So if I want x to be equal to 4, according to my scale, it doesn't look like this is true. What I need to do though is I click on the fulcrum of that scale, and I'm going to click balance. So that sets the x value equal to 4. So if I split this 4 apart, and I say, okay, one of those, now it's important that you see how that box is around the scale. It's important that all the parts are inside that box, otherwise it won't register. So I can see here that x is equal to 4. So if I take one away from the right side, sorry, I think I just messed things up a little bit. There we go. If I take one away from the right side, you'll see that it's not balanced anymore. I would need to take one away from the left side. So that's kind of the goal here, is let's say we start with an equation. Let's go back, let's start with an easy one. Let's start with x plus 2. X plus 2 is equal to 4, we'll say. And I'll write that out. Again, we can play around a little bit. This is the equation, x plus 2 equals 4. Cool. And we want to solve this equation. Well, if this equation is balanced, let's click on the balance in the center, click on the fulcrum and balance this. Our goal is to solve for x, so we want to get x all by itself. Well, how do we do that? Well, we can take one off on the left side, which means we also need to take one off on the right side. We can take another one off on the left side and take one off from the right side. So what we just did is we subtracted 2 from both sides of this equation. So we can show that algebraically, sort of like this, and that should leave us with an x on the left, and 4 minus 2 is equal to 2. That leaves us with x equals 2. And what happens if we had multiple x's? So had this equation said something like 2x is equal to, 2x plus 2 equals 4, we could have our 2x's here and set the balance and so on. And at the very end, we would just say, okay, well, we need to divide. We've got 2 individual blocks here, 2 1s on the right, and we have 2 x's on the left. So let's just make sure that each block gets an x. So I should be able to then take off these values. Of course, I didn't start with this, so it's not going to be balanced, but there we go. And then we can see if they're still balanced. So a nice, easy, visual way for students to deal with this. I used just positive examples here, and I used the number cards. Yes, you can use negatives as well. So if you wanted to use some negatives, we could totally do that. So for example, here we can click on balance, and we could split these apart and say, hey, let's pull this x and this minus 1 out. Sorry, I keep missing. There we go. And it's still balanced, but as soon as I take something off, it's no longer balanced. So let's put that back on so that it stays balanced. So those are the algebra tiles, and again, the balance for solving equations. It's a great visual for students. And again, after a while, students develop they see what's going on, and it's easy for them to develop the understanding of those inverse operations that we would use and talk about quite regularly in math. There's lots of other stuff here to explore. I'm going to stop here just because we've been talking for a while. Just a couple of interesting things maybe to note here. There's this function machine. So the function machine is kind of like a pattern rule. So in this case, the pattern is x plus 1, and so we can actually give it a whole bunch of x values, and it will spit out the corresponding y values. We could have students guess what that pattern is, so that's a great one for those patterns. And I haven't touched on any of the probability and data management. So in that probability, we can have all the randomization, dice, spinners, coins, a whole bunch of different kinds of dice. So if you're looking for 4-sided dice or 10-sided dice, you could do that here. And then there's also some fun games that students can kind of mess around with to kind of just strengthen their number sense. So I think I'll wrap it up there. That's quite a lot of information to go through. Hopefully you've learned something, and there's a good opportunity for you to kind of jump into something that might be useful for you and to help your students. Thanks so much.